So guys, today we're going to talk about things that are in focus and things that aren't in focus, and how much of stuff is in focus. And what's the term for how much of something is in focus? Depth of field. Basically the field of vision, how deep is the stuff that's in focus. The larger the aperture, the narrower that in focus plane becomes. If you have a really small aperture, that in focus area can become quite a bit larger. So the larger apertures have shallower depth of field. And you might think that would be a bad thing. It's like, oh, so only part of the image is in focus and the rest of it goes blurry. And if you're trying to represent the scene, like get the establishing shot of, here's the event, you want to get everything in focus. You'll probably use a fairly small aperture. But when you get down to doing the little detail shots, the little things around the event, or if you're just doing something to represent, say it's like an article on the whatever flower that's being used for whatever medicinal purpose, and you've got a whole field of flowers. If you use a really small aperture and you get all those flowers in focus, you might have this nice beautiful burst of color and a lot of detail everywhere. Which one flower are you specifically referring to? Maybe it's a field of different wildflowers and this is the one that they're using for the article. By using a very large aperture and a very shallow depth of field, you can lock the focus onto that one flower and everything else can go soft and blurry behind. So you can use that in focus to kind of draw the viewer's attention. I'll just show you some examples of that. First off, here's a row of typewriter keys that I took just to show the idea of depth of field. And this is with a large aperture. So you can see we have this line of focus down the front here. All this stuff here is in focus. Everything in front of it is out of focus, and everything behind is out of focus. And you'll also notice those circles that I was talking about. A lot of people think, well, when it's out of focus, it just goes kind of blurry. If in Photoshop you did a Gaussian blur, you'd get that out of focus sort of look. But no, we have these very hard-edged circles. That cone of light, when it comes down, if you cut the tip off, all of the light that was coming out of that point light source gets spread across that entire circular area. And there's a term for those circles. They're actually called circles of confusion. You'll notice, let's say you take a photograph of some Christmas lights or something. They end up as a bunch of colored dots. The red lights become a red circle, the blue lights become a blue circle. It's that cone shape that's kind of getting cut off. Now you notice there's a little bit of, the lenses aren't perfectly round, so there's a little bit of distortion around the edges there, but this is kind of the out of focus effect you get. When there's not a lot of point source lights though, it can look kind of just soft and blurry. When there's all the little individual points that are similar brightness, maybe different colors kind of blend together, you lose this definition of the circle there. But when something's out of focus, that's what it is, a whole bunch of circles like that. And you can use it, like I said, to kind of draw your attention towards the subject. Like let's say you've got the little hummingbird kind of fluttering across there. By locking the focus, and in this case these things are going so fast the photographer probably had it pre-focused and just waiting. When he came in, beak goes in, bird's in focus. The flower is in focus, so you can see where it's getting all this nectar from, but behind it's gone all soft and blurry, almost like an abstraction. And your focus gets drawn, your attention gets drawn to the sharpest parts of the image. So you can use that to kind of isolate your subject, okay? And that's going to be the assignment you guys are going to be working on. So let's talk a little bit more about this, uses of depth of field. I mean, it's not just a matter of trying to make things look more isolated. Here's an example of something really small. There's a little problem when you start getting close to things. The closer you get to something, or the more you try to magnify the subject, the shallower that depth of field gets. Let's say you're trying to photograph a fly. You got the macro lens. You guys ever taken really close-up photos with your camera? You get as close as you can, and it tries to lock on. It kind of goes back and forth, and it can't quite get it. With a DSLR, you can get macro lenses, which are lenses that let you focus really close to the subject. They'll often have ratios in the name, like a 1-to-1 macro lens means that it'll project an image onto the sensor that's the same size as the subject itself. So if you're photographing a fly that's, a half a centimeter long, it'll project an image onto the sensor that's a half a centimeter across. The problem is that depth of field will be really, really shallow. You can use a small aperture to try to get a bit of a larger depth of field, but you'll notice here, this is a full-size car, this is a little toy bus here, and look at how shallow that depth of field is. If you were photographing, let's say a mountain scene, you've got like a mountain off in the distance and some houses in the front, everything could be in focus. The farther away you get, the greater that depth of field becomes, and as you get closer, things get smaller. But let's say you're photographing a little model set, like a little miniature train set. About, mountains here, a little train across here. As you get closer to it, that depth of field gets shallower. What if you're photographing something that is so close that you can't get the whole thing in focus? There is a technique called focus stacking. You guys ever heard that term before? Like let's say you're photographing that fly, or in this case, you'd probably be, getting someone to photograph something for you, or, the latest microchip for this computer, and they want to get it, you want to get like an article about it and a photo where everything is in focus. If you get really close to something, that depth of field gets really shallow. Like if you try to take a photo of a fly with a big honking macro lens, you might get part of its eye in focus and everything else goes blurry. In Photoshop, there's a feature called focus stacking where you can blend them and it'll take the sharpest parts of each image. Here's a series of pictures that I took. It's a camera that I took apart. I teach also at Humber College, and this was one of their $40,000 Hasselblad H5D cameras. It died, so I got to take it apart. And I took the sensor out, because these things have like sensors this big, whereas your phones have a sensor probably like this big. So I wanted to kind of show the size comparison between a DSLR, this thing, and a phone camera. So I stacked all the parts up, and just for this focus stacking effect, you'll notice that this little screw in the front is nice and sharp and in focus. Gets a little bit blurry. Gets really blurry towards the back, but I did a series of pictures and I progressively moved the point of focus back. Notice that now this screw is getting really blurry. This is now nice and sharp, and as I go down, eventually this is in focus, this is really blurry. But we have all the elements that we need to join all this stuff together into one totally in focus image. Now you also notice that it shifts a little bit. When you move focus, the scale can change. Also see how it kind of gets a little bit larger. When you're focusing, the lens is actually moving back and forth. And if you move a projector, say, imagine the lens is kind of projecting that scene onto the sensor. As you move a projector further away from the screen, the image gets larger. So you'll actually notice there's a little bit of scaling as you're focusing thing. That lens moves back and forth, the thing gets larger or smaller. In Photoshop, you can tell it to load images as a stack. So let's say I popped into Photoshop here. I'll load up a script that says, load some files into a stack, and I'll navigate to that folder, and it was these images here. And I'll tell it to attempt to automatically align the source images. If you're doing a series of images, like when we talked about HDR, high dynamic range, you want to do a scene where the brightest details and the darkest shadows are all properly exposed, you'll probably end up having to do multiple exposures. Do a really dark exposure where the highlights are properly exposed, a really bright exposure where the shadows are properly exposed, and then you'll be stacking those things together. If anything moves, that alignment is going to be off a little bit. If it's just a little bit of misalignment, the software, when it stacks all these layers, all these files on top of each other, will attempt to automatically align those source images. I mean, ideally, the tripod will stay nice and still and you won't need to. But in this case, that scaling difference, that difference in size can make things a little bit more complicated. So I'm going to let the software deal with trying to stack those things up and make sure that they're all nicely aligned. So it's going through and it's opening every single one of those images. So there's the one where the background is in focus, so it started at the bottom image. And it's now aligning the layers. It's kind of putting them over top, shifting them around until everything lines up as closely as possible. It's looking for contrasting edges. And there's the last image where this is in focus. So here's all the different images. Let me just pull this layers panel larger. So here's the background in focus. There's that nice and sharp gear back there. But as we go, the body of the camera goes blurry. As we get towards the front here, this little screw, you can't even really tell what it is. It's so far out of focus. And you'll notice how much smaller this layer is than the rest of the image. Here's the one where the foreground is in focus. See how much larger it had to scale that image up. But there, this little screw here is in focus, this little piece of copper. But as we go towards the back, you can't even tell what that is back there. Now with all these layers stacked up, if we kind of go through one by one, there's the back, moving that focus forward. And I'll tell the software, take all of these layers and let's auto blend them as a stack. And when I hit OK, it's going to take the sharpest bits of each image. And this is what blows me away. When I first started in Photoshop back in 1994, it was a very literal program. You use the clone stamp, say, take these pixels from here, put them over there. You could do some color adjustments. Eventually, they got layer capabilities. And now, look at this. See these layer masks here? Remember on a layer mask, black hides, white reveals. The software has looked through each of those layers, found the sharpest parts, revealed them with a layer mask, and now we have an image where this back gear is in focus, this front screw is in focus, and everything is sharp from front to back. That's pretty impressive. And let me just quickly show you the layer masks on here. Like I said, the software is making decisions on sharpness. And if I turn off all the layers except, say, this one, this is right in the middle, and all the parts of the image that were sharpest in the middle, it kept. The layer mask, here's the mask that it made to hide all those other areas. And all of this blends in with the neighboring layers. As we move towards the front, there's the foremost image with the screws in focus, this little circuit board in focus. And as we move towards the back, there's the farthest image with that little gear and that little gear there in focus. Once they all come together, there's the entire image all nicely in focus.